Hello, my name is Nitya Shah, and my name is Nimay. We're here to present our app SmartECG for the 2025 Congressional App Challenge. Electrocardiograms, or ECGs, are the most commonly used diagnostic tool for diagnosing cardiovascular diseases. However, the accuracy of diagnosis from ECGs is very low, around 69% for trained cardiologists and 54% for general doctors, both of which are extremely insufficient. New methods have risen, such as machine interpretations, but they have shown even lower accuracy and they don't support the paper ECG, the predominant format in rural and developing areas. To address these needs, we created SmartECG. SmartECG is a comprehensive web application developed in Python using libraries such as Streamlit and TensorFlow. SmartECG takes a paper ECG and digitizes it into a digital format, which is then run for diagnosis of diseases. For the digitization algorithm, we conveniently extract the text markers at the start of each ECG lead to split the ECG into each of its leads. Then we scan through the ECG lead to detect the standout black wave, and those coordinates are saved to CSV, effectively digitizing the ECG. This data is run through the Pan-Tompkins algorithm to extract the RR interval peaks. This is fed to a random forest classifier to classify the diseases tachycardia, bradycardia, atrial fibrillation, and sinus rhythm. To diagnose STEMI or heart attack, we train a CN and LSTM model. This model utilizes two LSTM layers who are specializing in detecting changes in the ST segment over the course of the data, which is crucial for diagnosing STEMI. Both these machine learning models saw an accuracy of over 90%, significantly surpassing current clinical standards. We integrated all of these features into an amazing web application.
The user starts by scanning a paper ECG. Once the paper ECG is scanned, it is uploaded to our CardioSense app. When the ECG is uploaded, we prompt the medical professional to enter some basic information about the patient, such as their name, age, and gender. Once it is submitted, you can double check your scan by looking at an image of it. Then you will see all of the digitized lead. And the digitized lead is basically a process of converting the scanned image of each of the LEDs into a digital format with numerical data points. This can be valuable in giving a diagnosis, and in this case, it's tachycardia and non-STEMI. This is done through our machine learning and deep learning diagnosis models. Additionally, we have a diagnosis bot where you can talk about your results, future steps, and ways to prevent diseases in the future and in the past. As you can see here, this is a sample question being asked about the diagnosis and how it came, and then what in the future can be done to prevent this in the future. We also have a functionality for a medical professional to view a patient's history of diagnosis. Here we enter the name of the patient and we see the result we just got from the system. It shows all the information we entered about the patient as well as the diagnosis. We also detect the heart rate trend, which as of now